So A-level chemistry 4.1 isomers. I'm just going to run through this for anyone to use to catch up or just to get a head start on their revision. So start off nice and easy. This is like back to basics. This is last year in terms of AS chemistry, the different types of isomers. Okay, so structural isomers. They're ones that have got just a different arrangement. Okay, they've got the same molecular formula. So there's 3 different types: position, chain, and functional. Chain, nice and easy. It's often that the chain is just bent or branched, as we'd say, in a certain place. It's got the same molecular formula, but its name will change slightly to reflect this. Okay, positional isomer, again, nice and easy, something that we will have done loads, just moving where the functional group is. So it's just moved slightly. Again, the functional group remains the same, but it's changed to reflect the new position of the functional group. This one's a little bit different. So it's got the same molecular formula, making it a structural isomer. However, it's got different functional groups. This has got a cyclic functional group, that's got a carbon-carbon double bond, okay? However, if you were to look at them, they've got the same molecular formula, but atoms are arranged differently. So they're the 3 types of structural isomers, same molecular formula, different arrangement, okay? Moving on then to stereoisomers, okay? So stereoisomers have the same molecular formula again, but a different spatial arrangement of atoms. This differs from structural isomers because structural isomers for stereoisomers is the same. Okay, so their actual structure looks the same. Their main 2 types of stereoisomer are EZ and optical isomers. So EZ isomers are the isomers that we did last year. Okay, they have limited rotation around their double bonds. Their double bonds are where the rotation is. Okay, and remember, if they're like opposite each other, it's an E isomer, and if they're on the same side as each other, it's a Z isomer. You are looking at it like that. Okay, so you're looking at what's on this side of the double bond and then what's on this side of the double bond. And remember, there is a priority rule for working that out. Okay, so you're looking at the higher MR mass number essentially across this line. Okay, so chlorine has a higher mass number on this side between chlorine and fluorine, and bromine has a higher number than hydrogen. So these 2 are opposite each other, so it makes it an E isomer. Okay, that's all kind of like an overview and a recap from last year. So then we moved on to something called optical isomers. Okay, they're still stereoisomers, same molecular formula, different spatial arrangement. However, there is an asymmetrical carbon. Okay, so a carbon which has 4 different groups attached to it, and we kind of identify its chiral center, so the carbon with the 4 different things attached to it, normally using like an asterisk. Okay, so it has to be, how do you make an optical isomer? It has to be a carbon that has 4 different things attached to it. Okay, so these type of isomers then, normally you have 2 of the isomers and they're mirror images of each other. So if I was to place a mirror along here, they would be mirror images of each other, essentially a flip of each other in a mirror. Okay, and these 2 different isomers are called atomers. So atomers are 2 different of the same 2 isomers, essentially 2 different isomers with the same compound. Okay, these atomers then will rotate plane polarized light. So optical isomers are optically active. That means they have the ability to rotate light. So each atomer will rotate it one way or another. Okay, so if they we call them clockwise or anti-clockwise isomers. Sometimes they're called R and S, or sometimes they're called positive or negative. Okay, so clockwise is positive, anti-clockwise is negative. Okay, they have the ability to rotate polarized light 90 degrees in opposite directions. That's how we can work out if we've got 2 different atomers and what type of an atomer we have. Okay, racemic mixtures then is another new word. Okay, so a racemate or a racemic mixture, doesn't really matter which word you use, have equal quantities of each atomer, so it wouldn't rotate the plane of polarized light. There'd be no overall effect because it's optically inactive, because you've got half your mixture going clockwise, half your mixture going anti-clockwise, so they kind of balance each other out. Okay, racemic mixtures are often formed in nucleophilic addition. Okay, because you're looking across a carbon-carbon double bond or an oxygen double bond. Okay, something that's quite planar. Okay, so these 2 here, just adding on a cyanide. It doesn't have to be cyanide, it could be adding on a hydroxy group. They've just picked cyanides for this one. You're adding on a cyanide, okay, and you've made this. So it's an extra carbon long, okay? But depending on which way it comes out, it could be that way, the cyanide's on this way, or cyanide's on that way. They're basically mirror images of each other, so that's a racemic. Normally nucleophilic addition, so the adding of a nucleophile causes this.